Hi everyone, welcome back. We have one more distinction to think about with the PPF, right? Our new model in chapter 2. And that has to do with the shape of the PPF itself. So, and to think about this, we're going to think about opportunity cost. Now, I didn't specifically say this, but we did think about it a little bit with regard to pizzas and strombolis. But there is one thing that is clear on this graph, and that is the opportunity cost. Because if I have some maximum, if I have a y-intercept, right, or pizza intercept here, a maximum number of pizzas that I could make if I made no strombolis, and some maximum number of strombolis that I could make if I made no pizzas, and I have a PPF that connects them, then one thing that's evident on this PPF is opportunity cost, right? Because if I make, well, let me label these 2 points here. If I call this point, this production possibility A and this one B, then to move from one to the other, notice these are both efficient points. They're attainable and they're efficient because they're on the PPF. But if I want to move from A to B, that means in this movement from A to B, I'm going to gain additional stromboli, right? I have more stromboli at B than I do at A, but, oh, what happened there? But to get there, I have to give up pizza. And so there's a trade-off, right? That's the opportunity cost. I give up one to get more of the other. And everywhere along here, right, everywhere along the PPF, it represents a trade-off, right? There's some change in one good to get more of the other. You give up one to get more of the other. So the opportunity cost is evident. The opportunity cost, and you could move, let's say we'll call this C and D. And moving from C to D, I get more pizza, but I give up stromboli. So on the PPF, in a simple world where there are only two things that we can produce, the opportunity cost of producing one is always going to be the other. Right? If I want to make more pizza, well, I should say if I'm on the PPF, so if I'm producing at an efficient point, if I want to make more pizza, I have to give up stromboli. And if I'm at some point on the PPF and I want to make more stromboli, to move from this pink spot to this one, to have more stromboli, I'm going to have to give up pizza. That's just the way it works. Now, note that if I'm at an inefficient point, then if I'm down here, I could move up and produce more pizza without having to give up any stromboli, right? Or vice versa, or I could move out in this direction. So if I'm at an inefficient point, then there doesn't have to be a trade-off. But most business owners were going to want to operate at an efficient point, and if you're on the PPF, then producing more of one means giving up the ability to produce some of the other. So opportunity cost is embodied in the PPF itself. So now we want to think about the shape of that PPF. So far, I've always drawn it as pretty much a straight line. I haven't maybe said anything about that, and that I think is realistic for some productive, enterprises. But when that's the case, what's a good color to highlight this? Then the opportunity cost is always the same, right? The opportunity cost up here between A and B and C and D or D and C and then these other points down here, the opportunity cost is always the same, right? The number of number of pizzas I have to give up to get some given quantity of stromboli is the same everywhere along here. Why you can tell that? Because the straight line has constant slope, right? Constant slope means constant marginal opportunity cost. So constant marginal opportunity cost, or what the book calls, well, I think they do call it constant marginal opportunity cost. That means you have a straight line PPF. Right, so the slope is constant. Everywhere you pick any 2 points on there and the slope is the same, right? The number of units that you give up of one good in exchange for the change in quantity of the other is going to be the same, right? That ratio, that's what gives you the slope, right? Rise over run, or in this case it's negative, but that fall, that's going to be the same everywhere along there. But is that the case for all goods? So I want you to think about these apples. Imagine that you have an orchard, a small hobby orchard, right? Not a commercial one, just one behind your house. You live on an acre, half of land, and you have a nice orchard, and you have enough trees that you could pick all of the apples in a weekend day. Like so some Saturday you could pick all of the apples in your orchard, but it would take you all day long. Right? So I don't really know how many trees that is, but that's how many trees you have. And imagine that you have just two kinds of trees, right? So you have empires, right? Empire apples, and you have Granny Smiths. Those are your two kinds of trees. And you have enough trees that you could pick empire apples all day long. And let's say that, let me make this a little bigger. You could pick empire apples all day long, and you wouldn't run out of apples, but you also, you'd pick most of by sitting there all day long, you'd pick most of your empire apples. And you have the same thing with Granny Smiths. You could pick Granny Smiths all day long and not run out, but you'd pick most of them. And the reason that's important because I want you to think about the art of actually picking them. All the apples are not perfectly evenly spaced throughout all the trees, and all the trees are not the same size, and every tree doesn't have the same number of apples. Some places, maybe it's, some trees will have more apples than others. Some apples will be easier to get to than others. Some of the apples are right there at sort of chest height. You can pick them right from the ground. Other ones you have to climb up in a ladder or climb the tree to get to. So if you're going to pick empire apples all day long and not run out of them, but at the end of the day you would have picked most of them, then every single apple you pick is not equally easy to get. Some of the first apples you'd pick were probably pretty easy to get to. Like I would probably start with the apples at chest height on a big fat tree, on the sunny side where there are lots of apples, and I'd fill my crates pretty quickly. And then I'd move on to another tree that had a lot of apples that were easy to get to. But eventually, after the easiest apples are all picked, I have to move on to some of the ones that are a little harder. So a couple of smaller, scrawny trees, or trees where I have to, go back to the trees that I have to climb up in them. And so basically, by the end of the day, even if you assume away human fatigue, right, or the fact that you get tired, at the end of the day, you're not picking the apples, not filling the baskets as quickly as before because it's just more work. It's different to get to. So here's where it gets interesting. Imagine that we had picked empire apples all day long, and so here's the maximum number of empire apples you could get in a day. And now imagine that we're going to rewind. And if we're on this vertical intercept, the empire intercept, right, that max number, it means we've picked exactly 0 Granny Smith apples. Now imagine that we could rewind the last 20 minutes of the day. So you get in your DeLorean and you set the time, for just 20 minutes ago, and you relive the last 20 minutes of the day. And so all day long you pick empires, except the last 20 minutes of the day you pick Granny Smiths. So the question is, how many empire apples do you give up, and how many Granny Smiths do you get in exchange? In terms of how many empires you give up, well, you're giving up the last 20 minutes of the day where you're climbing around near the top of a scrawny tree. And so those last 20 minutes, how many apples do you give up? Well, you give up some, right? You'd give up some apples, but maybe not all that many. And how many Granny Smiths do you get? Well, you haven't picked any Granny Smiths. So in those 20 minutes, you start with a big fat tree with a whole bunch of apples on the sunny side, like right at chest level. So could you pick a lot of apples in that time? Well, yeah, you might. You might actually gain a lot of Granny Smiths by giving up just a few empire during those last 20 minutes of the day. Would you see that? But what if we go to the other extreme? What if, in a different world, you had spent all day long picking Granny Smiths, and so you had the maximum attainable number of Granny Smiths with no empires. But what if you said, well, what if I had reallocated the last 20 or 30 minutes of the day to empires? In a world where I hadn't picked any empires and I just picked Granny Smiths, I have all these Granny Smiths. The last 20 minutes of the day, I'm only giving up a few Granny Smiths, but I might be able to gain a whole bunch of empires. And so what you see is that there are other combinations of empire and Granny Smith, but they don't fit on a straight line. They fit on a curve, right, a frontier that bows outward. So where the increasing marginal opportunity cost, that's up here, right? Increasing marginal opportunity cost, because the longer you pick the same thing, the more of the other you give up per. So the longer I pick empire apples, the more Granny Smiths I give up per empire picked. Every time I pick one more empire apple at the end of the day when it's really hard to get to, I'm giving up multiple Granny Smith apples per empire apple gained. So that's why we call that increasing marginal opportunity cost. And increasing marginal opportunity cost, that gives you this bowed out or concave shape. Like, so concave with respect to the origin, right? Or you could just call it bowed out. But that corresponds to increasing marginal opportunity cost. Here's one more way to think about it that isn't even graphical. I'll leave this here while I talk about it. But imagine that a friend of yours, not you, because you're going to be on top of things. I know each of you will study well in advance. You certainly won't, just cram the night before an exam. But imagine that your friend who's taking Econ and Chem 103, right, or challenging chemistry class. And it turns out that their first midterm in each class is on the same day. So let's say that you've got it right in a row. So it's on a Wednesday, and so at the 10 o'clock hour, whatever the official 10 o'clock time is, a little after 10, you have chemistry, and then at 11:15 you have economics. You have them right in a row, and your friend is just going to cram the day before. So they're going to start studying at 2 o'clock in the afternoon. They're going to study until midnight. So they've got 10 hours to study, and they're going to try to get some sleep, and they're going to get up and go take their exams the next morning. So if you have 10 hours to study, really they're going to cram, right? And this is because your friend was not on top of it, didn't study along the way, is not as prepared. And so they've gone to class, they've half paid attention, taken some notes. That says cram, that's hard to read, isn't it? Let's try again, a little bit neater. There we go. So what do you think you could learn in the first hour of chemistry study? The first hour that you study chemistry. So this is from not studying at all to that first hour, and you're like, oh yeah, there's this periodic table, and there's atomic numbers and atomic weights, and I have some idea of what they mean and understand a little bit about reaction. So does 1 hour of study get you a great excellent grade in chemistry? Probably not. You could get a pretty crummy grade, but would you learn a lot? Would that 1 hour of study in chemistry help you increase your grade a lot? So let's say that you studied, your friend didn't study at all. Maybe they get a 30%, on the test. Let's say they studied for 1 hour. Maybe they could get a 48, right? Which is a pretty lousy grade, but it's an increase of 18 points from studying that 1 hour, right? So the marginal benefit of studying that first hour might be really, really big. If you study a second hour in chemistry, do you think that would get you another 18 points? Yeah, I don't know. But it might still be pretty useful, right? A second hour of studying chemistry might still increase my grade by a nice chunk. I don't know, 12 points? I study a third hour. Can I expect to see my grade go up? Hopefully my expected grade would increase, but would it increase another 18 points or 12 points? I don't know. So what if we went from a 30 to a 48 to a 60? Would another hour of study get you from a 60 to a 67? Maybe. You had another 7-point gain. Study for another hour. Could you increase your score some more? Yeah, but after some point, you're getting down to the finer points. Because one, you're still just cramming the day before, right? So you're probably not going to develop real, true understanding of all these concepts. But you're just looking for, how can I learn enough stuff to do better on the exam? So you keep studying chemistry. You might expect that additional study will lead to additional, points, but we're not talking about 18, 15, 12 points, right, for each hour. As you get to these, finer details, maybe another hour of study buys you another, 3 points or 2 points or 1 point. So, does that make sense? Again, I asked the question. This is a video, so I won't hear your answer. The longer you study chemistry, the smaller the expected gain in chemistry. But then what do we call this? Increasing marginal opportunity cost. Well, why do we say that? Because every hour that I'm studying chemistry, what am I not studying? Econ, right? So in our example, you had 10 hours to study your cram, and you could study econ or chem. So every hour that I study chemistry, I gain points in chemistry, but I forego something, right? I give up the chance to be studying econ and to be getting expected increases in my score in econ. So there's an opportunity cost. The opportunity cost of studying chemistry is studying econ. So the opportunity cost of gaining points in chemistry is points in econ. And remember, this is your friend, this is not you, who did not really pay attention and keep up that much during the semester and now is just cramming the day before. Do you think that first hour of studying in econ would be useful? Do you think that would expected, score would go up? Probably. It would probably go up a lot. In 1 hour, you'd be like, oh yeah, PPF. I know what that looks like. I can fake it on a graph, right? I can get partial credit by drawing something. Supply and demand, yeah, I've heard of those, right? Scarcity, opportunity cost. In 1 hour, you could at least become familiar with the buzzwords, right? With some important ideas. And do you think that would help you increase your score? Probably. Now, does that guarantee you, or does that sort of get you a really great score? Probably not. But does it increase your score a lot? That's very possible, right? Let's say that first hour of studying econ could give you a 15-point bump in your score. Would the second and third and fourth hour, continue to increase your score by an expected 15 points? Probably not. It's probably going to get smaller. And by the 8th or 9th or 10th hour of study, how big are those gains going to be? Probably significantly smaller. And so here's the thing. If you studied chemistry for 5 hours, 6 hours, 7 hours, 8 hours, you're getting smaller and smaller gains in chemistry, right? Your expected score increase in score might be 5 points or 3 points or 2 points or 1 point. But the longer you study chemistry, the longer you put off studying econ. And what's the benefit of that first hour of econ? Maybe it's like 15 points. So every additional point in chemistry is costing you a whole bunch of econ points the longer you progress. So the longer you keep doing the same thing, the greater the opportunity cost. Let me write that out. The longer you pursue the same thing, the greater the opportunity cost. And where that's true, this is not true in all productive enterprises, right? All aspects of production. But if this is true, then you have increasing marginal opportunity cost. And that means that your production possibilities frontier for these two goods will be bowed out. It will look like that. That's increasing marginal opportunity cost. It's what in the book they call the law of increasing relative cost. So Mateer in the book calls it the law of increasing relative cost. Just understand that is exactly the same thing. So that's the other nuance that I wanted to talk about, the shape of the PPF. I'm not going to expect that you would know for a given industry if I talked about refining oil or building cars or, performing tasks in the library, that you would know the shape, but you should know what shape corresponds to what kind of opportunity cost. So if in a problem on the exam or on a homework or something, I said, draw a PPF for these two productive activities, assume that they exhibit constant marginal opportunities to scale. Constant marginal opportunity cost. Sorry, I got a different concept mixed in there. If I tell you it has constant marginal opportunity cost, you should draw a straight line PPF. If I tell you that it has increasing marginal opportunity costs, then it should be more bowed out. It should be more concave. So you need to know these two scenarios and what they look like graphically. So there you go. That's the shape of the PPF. Be familiar with that, straight line or bowed out, concave relative to the origin, and know what that corresponds to in terms of the marginal opportunity cost. And so I guess to finish this out, if it's increasing, right, then you have one that is concave relative to the origin or bowed out. So there you go. That covers that model, the first model that we're going to talk about, the PPF. And if you have questions,